Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. So, in today's video, I'll be focusing on grade 11s, to be more specific. Grade 11s, yes, grade 12s. I think this topic you inherited and then move on with it to grade 12s. But some of the things that we're going to discuss here, actually, everything that we're going to discuss here is very important for both grade 11 and grade 12s. But for grade 12s, it is unique when we do electrochemistry. It becomes a little bit unique. For now, let's say it's just for grade 11s. And then now, basically, this video is based on redox reaction, okay? Redox reaction, reduction, oxidation reactions. But for now, I want us to come to a concept of knowing exactly what is oxidation number, because this word is going to come quite a lot in this topic, okay? So we need to know what exactly are we dealing with before we can go to more complex things, if I may say it like that. Okay, so now first thing first, what is an oxidation number? Okay, so an oxidation number, it is a number assigned to an element in a chemical combination which represent the number of electrons lost or gained by an atom of an element in a compound. Okay, so what exactly do I mean? Uh, this is just the number that is assigned to each and every element in a chemical combination, which represent now the number of electrons, as it says, lost or gained by an atom of an element in a compound. And each and every group has its unique what? Its unique oxidation number. Okay, oxidation number, it's almost similar to valence electrons. Okay, if I may put it like that, if I still remember it very well, it is similar to valence electron, where we say here the valence electron, it is plus what do you say, 2 plus, and then group 3 it's here, 3 plus, and then we skip this one we say it's plus or minus, whatever, I don't know. And then we say this is 4 plus. Okay, let me come here. Minus, 2 minus, 3 minus, 4 minus, basically. So 1, 2, 3, 4, 5, 6. Okay, I think 1, 2, 3. I think this is plus or minus 4, if I'm not mistaken. Yeah, I think this is plus or minus 4. Yes. And this one, I think I can't even remember very well. But yeah, this is what we refer to as oxidation number. So we're gonna work a lot about that one. So we say oxidation number refers to whatever that I have already explained. Let me make an example. Those in group one, can you see they are in group one? They have a what? They have an oxidation number of plus. Okay. Okay, they have an oxidation number of what? Of plus. And then those in group 2, they have an oxidation number of what? Of 2 plus. And then those in group 3, I'm not sure which one is group 3. I think it's one, it is 3 plus. And then this one is going to be minus. And then, okay, I'm lying. Okay. These are the noble gases. They have 0. I need to start from the halogen. Minus, 2 minus, 3 minus, and then plus or minus 4. Exactly. This now makes sense. Okay, this now makes sense. And take note, I'm saying 3 minus, 2 minus, and minus. For the oxidation number, I start with a number and then a sign afterwards. Okay, so this is what we refer to as an oxidation number. Let me try to explain the concept where I said now represents the number of electrons lost or gained by an atom. Let's say, for an example, consider now X plus. Okay, X plus. So X plus tells you that X atom lost 1 electron. Okay, and its oxidation number its oxidation number is equal to. Now, I want you to take note of this. When we write it in an element, we say in an element it is X2 plus, okay? This is how we write it. But when we refer to its oxidation number, we're going to say it is plus 2. I know it's a little bit confusing, but when you write an element, you're going to say an element has 2 plus here, but when you refer to it, when they ask you what is the oxidation, what is the oxidation number of X, you're going to say it is plus 2. Okay, why? Because we're going to be using these to calculate. Okay, we're going to be using oxidation numbers to calculate. Okay, yes, so it is an oxidation number. From now on, I'm going to refer to as oxidation, sorry, oxidation, oxidation number S. I'm going to refer to oxidation number as ON from now on, okay? So the oxidation number, it is an oxidation number of, remember when you refer to oxidation number, since when you're going to be doing calculation, I'm going to say it is plus 1. Okay, people might confuse this and say, okay, it is positive, so why does it lose electrons? Well, remember, an element, let's consider element X. Hence, we are saying X lost an electron. Why? X element has equal number of, it is neutral, basically. Let me say X, it is neutral. Okay? When X is neutral, it has an oxidation number of 0. We will explain that further. Okay? It has an oxidation number of 0. This does not mean it does not have electrons or rather protons. It does have electrons, but it means now it is balanced by equal protons. Okay, equal protons. So can you see everything cancels out because there are 3 protons and 3 electrons. But now we say X atom lost 1 electron. So when it loses an electron, when it loses one of the electron, can you see now the charge that is left is going to be 3 positives. Okay, let me say 3 I'm not sure. Let me say uh, so basically this, okay, let me do this. Basically what you're going to be left with is, let me remove an electron. So can you see that this P is going to cancel this E, and then this P is going to cancel this P. But can you see that we are left with a net charge of what? Of plus. Hence now we are saying when it is X plus, it means it has lost what? Electron. When you lose electrons, you become more positive. When you gain electrons, you become more negative. I hope that makes sense. And if you are having Y 2 plus, maybe it means now the Y atom lost 2 electrons, and then its oxidation number is going to be what? Remember, for mathematics, plus 2. And then let's consider Q minus. So we're going to say Q atom did what? Remember, when you become more negative, it means you have gained an electron. I'm going to say an electron. Okay, let me just say 1 electron so that it does not confuse others, the English. So its oxidation number is going to be what? Minus 1. Guys, when you write down the oxidation number, it's very, very important to write the sign and then the number, because oxidation number, you won't, when you ask you what is the oxidation number of Y2 plus, you won't say it is just 2 because it's positive. We need that plus. Okay, yes. And then let's consider the last one, R 3 minus. It tells you that Q atom gained 3 electrons, and its oxidation number is going to be equal to negative 3. All right. This makes sense, right? This makes sense now. Okay. Now we have rules. Okay. We have multiple rules of of using now This oxidation number, let me do this. Rules of oxidation number. Oxidation number. Okay. Now let's look at those rules. What do they say to us? The first one, we need to consider the convention. The conventions refers to the sign, okay? We need to consider the conventions. What about the conventions? So we say when we write down the oxidation numbers, we start first with the cations and then we then conclude with the what? With the anions. So we say with regards to the conventions, we say cations. Remember, cations are positive ions, okay, are written before anions. You still remember cations and anions from grade 10, right? If you don't, it's fine. We say it is a cation if it is Ca2 plus, it has a positive charge. Okay, so it has charge, no positive ion. So it is an ion when it is, let me see, NO3 minus, it is an anion, okay, positive cation. So yes. So we start with when we are given a compound, basically, we start first writing down the convention by saying, okay, we start with the positive ones and then the remainder will be the negative ones. Mpo, what do you mean? Mpo means that if I'm having sodium chloride as a compound, what I'm gonna do, I'm gonna break this into two. Okay, so this is gonna break into sodium and chlorine. Okay, but now we start first. The convention says start first with the cations, which one is positive between the two, the sodium. So it's gonna be sodium plus, and then the last will be what? Cl minus. Similar when I have HCl, okay, it is H plus, and then lastly the Cl minus. Well, okay, let me just leave it like that before. Oh, okay, this is very important. This one. Let me do this one. Consider sodium hydride. So when I break sodium hydride, it's gonna be. So remember that I'm used to sodium. I'm used to sorry, hydrogen being H plus, but now we need to consider between sodium and hydrogen, which one now is stronger. Okay. Remember in grade 10, I can't even remember what we referred to that. But as you go down, the strength of the what, I can't even remember the right word for that, increases. Again, the I'll say the strength of the, I don't know when you refer to the radius of the what, and what. But now, what I'm just gonna say now to you now is that as you go down, it becomes stronger. Okay, as you move down, your positive becomes strong. Okay, it becomes strong. So now you can see that sodium, it is stronger than hydrogen. Okay, sodium is stronger than hydrogen. I forgot the word. These ones we refer to electronegativity. We have yeah, guys, I can't even remember. But yeah, I use this analogy that as you go down, the positive becomes stronger because they are all plus ones, right? But now as you go down, it becomes more stronger. So it means sodium is preferred first, and then this one will be H minus. Why? So that when I say plus one minus one, it gives me a charge of zero, which we will discuss now. We will discuss, okay, why the charge needs to be zero. Okay. Now the second one, remember this was the first one, convention. The second one we're gonna refer to the oxidation number. The oxidation number, oxidation uh, oxidation number, of a free element, okay, is 0. An oxidation number of a free element, it is 0. But what do you mean now? An oxidation number of a free element, it is 0. What I mean is that if I have an element, guys, I'm talking about an element. Okay, let me make, guys, some people don't know how to differentiate between an element and a compound. This is an element. This is a compound. A compound consists of two elements, or rather, it consists of elements. Okay, this is a compound. A compound. This is an element. Okay, yes. So let's consider what is this? Any free element that we might take note of. Now, sodium. Sodium, as we're talking about sodium. Sodium has an oxidation number of 0. Okay, and then another example, maybe magnesium. Magnesium has an oxidation number of 0. I can make a lot of examples. I can make a lot of examples with this one, guys. And again, what can I say again? I can use any element, guys. Zinc has an oxidation number of 0. What's important is that the oxidation number is 0. Okay, if it's just a pure element, okay, the oxidation number of free or pure element is just 0. Okay, let me go to statement 3 so that you understand better what I'm trying to explain here. Now we say in number 3, the oxidation number, okay, of a monoatomic ion is the charge on the ion. Big words. Yes. Now I'm saying the oxidation number of a monoatomic ion. Remember what is mono? Mono means one. So monoatomic ion is the charge on the ion. Big words. Okay. No, big words I know, but now illustration will make things become simpler. It means now if I have Na plus, okay, this is what I refer to as a monoatomic ion. It's no longer an element. An element is just pure. Okay, let me just rephrase this to of a pure element is that I get, and then now a monoatomic ion is the charge on the ion. It means now the oxidation number. Okay, the oxidation number of this one, it is what? Remember, we say plus one. Okay, we just say plus one. We don't say one, just one I, it should be plus one. And then another example that Mpo might make is that Cl minus, it is a monoatomic. Guys, when I refer to monoatomic, I refer to this, not this. This is not a monoatomic. We will come to this type of things, but not now. Okay, not now. Cl minus, it is what? Its oxidation number, it is -1. And then the last one that I might make, I think aluminum ions, and then its oxidation number is going to be +3. Guys, what you see here, when you write the oxidation number, you just flip the sign and the number, guys. Okay, please, please, please don't make that mistake. But I believe in you guys. Now, let's go to some interesting stuffs. Né? Let's go to some interesting stuffs. We say, remember there is this, okay, okay, okay. Let me come back here. When we considered this element here, I said H is gonna take the minus Y because Na is strong. Why it is a stronger what? What do I mean Na is strong? When Okay, it has a stronger ability as you go down, the ability to lose an electron, if I may say, the ability to lose an electron is higher. Okay, as you go down, the ability to lose electron is higher. Okay, so number four, let's say uh, the oxidation number of hydrogen is +1, except, except, ouch, except in compounds that have that have less electronegativity than H. Well, you did in term one or term two, if I'm not mistaken, somewhere there, what you refer to as electronegativity. Electronegativity refers to the ability of an element to acquire electrons. Okay, to acquire electrons. So now these I said as you move down, as in group one, as you move down, it means now you increase the chances of being more positive. Okay, you become more positive, and as you become more positive, you have less chances of acquiring electrons. Again, so when you prefer being more positive as you go down, you prefer being more positive. Hence, now if I were to compare between H and Na, H has a higher electronegativity than Na. Why? Because this one, the strength of being more positive as you go down. So this one is, yes, it is plus, but this one it is more plus. Well, what I'm saying does not necessarily make sense, but please try to imagine it the way I imagine it. So as you go down, you become more plus, more positive. Okay. Yes, the charge is still the same, plus one, but now you become more positive. Therefore, making this one to have more electronegativity. I think when you refer back to your electronegativity and all of that, you'll see what I'm trying to explain here. Let me make an example. An example. Okay. Check now. I'm saying the oxidation number of hydrogen, it is +1. +1. Can you see? It is +1. I did mention that, just that I'm going to explain. Can you see? It was, where is it? It is +1. But we had an exception. Okay. That exception says if now, this is me taking account of this exception. If Na is less electronegative than this one, it means H has the ability to acquire electrons more than Na, because Na, as you go down, you become more positive. Again, you have the strength to become more positive. It means your strength to acquire electrons decreases because you have more strength to be more positive. So this one has the ability to acquire more electrons than Na. Hence now H says, you know what, it's fine, I'll take the electrons. Therefore, if I consider this one, an example on this one, if an example of lithium hydroxide, sodium hydroxide, sodium hydride, lithium hydride, sorry, not lithium hydroxide, guys. So hydroxide is like this, lithium hydroxide. Sorry about that. Lithium hydride, sodium hydride, as well as calcium hydride. Then the oxidation number of what? Number of hydrogen. Hydrogen is -1. This is an exception. Okay. So, okay, let's consider. Can you see? These ones, as you go down, the ability to acquire electrons decreases because it has the strength to become more positive. And as you go to that side, well, beryllium, magnesium, and calcium, well, the strength to become more positive, it's high. I mean, if I were to compare H and Ca, can you see this one is more positive? So this one, you require a lot of electrons. Okay, so H will be like, you know what, it's fine. I'll take those electrons. We're not just remain positive. Okay, so this is this example that I have here, H plus. So remember the rule that I talked about, that when I do these ones, when I consider calcium hydride, okay, let me combine it hydride. When I want to break it, now what happens? What happens is that I need to start with the one that is more positive. Okay, remember it says cations before anions, but now both of them are cations naturally the way we know it. But now, which one is more cation? It is Ca. And I want you to remember this part. Remember when you had C in grade 10, you learned how to combine a compound. You had H plus and oxygen 2 minus. So we said they swap. What exactly swaps? The numbers. So it's going to be H, and then the number here, which is 2, comes here. And then we have oxygen, we write it exactly as it is. And then the O number, which is 1, comes here. That when we refer to valence electrons or whatever. Can you see? This is how we get water. So in reverse, when I reverse this, I'm going to say this 2, this is 1. Ne? This 2 needs to come here. This 2 needs to go back in reverse, basically. In reverse. So it means the H needs to acquire its 1. I'm going to just try it 1. I'm not sure which one is it. And then the oxygen needs to acquire its 2. But we know oxygen from our periodic table, it is the negative one. Okay? It is negative. So we're going to say, okay, it means it is minus 2, not, okay? No, not minus 2, 2 minus, I guess, and then this one requires to be plus. So we are working in reverse. That is going to help us a lot, guys. You'll see. That is going to help us a lot, especially when you consider such calcium A2. So remember, in reverse, it means now calcium had 2 plus and hydrogen had. So remember, for compounds to combine, we need a positive compound as well as a negative so that they combine the off. Okay, and then it means this one was what? Was minus. It cannot be plus and plus. It cannot happen. Can you see? Can you see, guys? Yes, I hope it makes sense. I hope it makes sense. Hopefully it does. Hopefully it does. Now I was on number 4. Let's go to number 5. Okay, I think I have 9 of these rules thereof. On number 5, I'm being slow, guys. I'm taking my time so that you understand these things. Number 5, the oxidation number. This is another exception. Oxidation number of oxygen is -2, except in peroxide. Except in peroxide. What do you mean in peroxide? It's peroxide such as hydrogen peroxide, like this. So in this case, the oxidation number of uh, in this case, the oxidation number of okay, except in peroxide such as H2O2, where the oxidation number of oxygen is -1. Ha! Okay, okay. Well, okay, can I prove this? I mean, I can't come with something and then can't prove it. Remember, if I have H2O2, what did we say? We say we need to start first by the cations, okay? And I know H2, it is a cation, okay? I know H2, it is a cation. It is positive, okay? It is positive. But now, how many positives do I have? I have two positives, so it's going to be plus 2, okay? I mean 2 plus. So it's going to be H2 plus, okay? Oh, another thing that you remember I said, guys, remember I said the atom here down there needs to go in reverse. So it's going to be H2, let's say O2, okay? But this we know needs to be positive, this needs to be negative. But now can you see that we need to divide both sides by 2, since well it is 2 is to 2. It means it can be H plus and then O minus. Can you see that? But I'll explain it more thoroughly when we now go to how to calculate an oxidation number in a compound, okay? Where we say the net charge here on this type of into, it is 0. The net charge, can you see there is no plus here, there's no minus, so the net charge is 0, where we will say, okay, I know there are two hydrogens and then it's a oxidation number, it is normally plus 1, plus oxygen we do not know, so we're going to say there are two oxygens, okay, is equal to 0, and then solve for oxygen is going to be 2O is equal to negative 2, and then oxygen is negative 1. But we look more into this as I do now calculations of oxidation numbers. Number 6, halogens have oxidation number of negative 1. The halogens, our periodic table does say that the halogens here, they occur. And then number 7, this is what I want us to now come to. It says neutral. Yeah, it's very important between compounds and all elements. Neutral compounds have a net, okay, a net oxidation number, of 0. What do you mean, Mpo? Mpo means that if I'm having an element, sodium chloride, the net, the net, the net oxidation number, it is 0. How? The question is how? The how part is that, remember it is Na plus and Cl minus. So can you see when I say oxidation number? So when I calculate my net oxidation number is going to be plus 1 minus 1, which it is equal to 0. Now, I hope that makes sense. When a compound, it is just neutral. Okay, neutral compounds, guys. Very important. Neutral compounds have a net oxidation number. Oh, guys. Net oxidation number of how much? Of 0. I can make another compound, guys. Whatever compound, MgO, magnesium oxide. I think it's like this, magnesium oxide. It has a net oxidation number of how much? Of 0. And then let's see on number 8. Maybe this will make number 7 make sense. The oxidation number, guys, you are taking notes, of a compound ion. Can you see? I'm no longer saying of a neutral ion. I'm now saying of a compound ion. Okay? The oxidation number of a compound ion is the charge. Okay? Yeah, is the charge of the ion. And what do you mean? Remember we said a monoatomic element is the oxidation number of a monoatomic element is the charge on the ion, meaning if I had Na plus, the oxidation number is just +1. But here, when I have a compound, I need to refer to net charge, ionic charge. So let's make an example. Consider me having SO4 minus. What is the net oxidation number? The net oxidation number of this compound, it is what? -2. Okay. Another example, these ones, they like it. This one, this is going to appear a lot of times when you do question papers. Try to do as many question papers. This has an oxidation number of how much? Of -2 also. Why? Because it says the oxidation number of a compound ion. Okay? A compound ion, it is a compound that has an ion. Remember, a compound, it is a combination of two things, guys. And then an element is just one thing. Is the charge of the ion. Is the charge of the ion. The oxidation number is the charge of the ion. Remember, when I write oxidation number, I just flip them -2 instead. Guys, I think this should make sense. This should make sense. And on number 9, well, this is what you already know, oxidation number per group. I already explained that in a periodic table, but I'll just write it per group. When I have group 1, group 2, group 3, and then I have group 7, 6, and 5. Remember, they have their respective oxidation number. Group 1, it is plus. Group 2, it is +2. Remember, I'm talking about oxidation number. Group 3, it is +3. Group 7, it is minus. This one, it is -2. This one is -3. And this tells you that they are positive again. So if, remember what causes you to be positive, it is when you lose an electron. Okay? So these ones loses. I'm not sure loses is written like this. Loses electron. Okay? Let me say lose electron. Yo, the English here, these ones gain electron. Remember, I will make an example in case you've forgotten. I said if you have an element like this, okay, it is surrounded by electrons, by electrons, by electrons. But that does not mean that it is, especially when you're talking about a neutral. Let's talk about Mg. A neutral, never mind Mg. Let's talk about X. It is just a neutral element. So it tells you that it has equal number of protons and equal number of electrons. Okay? It does not necessarily mean it does not have electrons or protons. They are just balanced. Okay? But now, when I get X plus, how do I become more positive? For me to become more positive, we need to get rid of the negatives. So it means on this one, I have less electrons, but I have more protons, guys. Oh, that makes sense. I know. I know. And then how do I become more negative? I become more negative if I want to do what? If I want to become more negative, I need to eliminate the what? The positive. Meaning I need to have more electrons than what? Than protons, guys. This is clear. There's nothing clearer than this one. Okay? Remember, we are saying this one is neutral. This one is negatively charged. This one is positively charged. Okay. Guys, now I've talked a lot. Let's consider examples of calculations. Example. Consider, let me not say consider. Calculate the oxidation number of the elements mentioned in a compound. Okay, now let's do that. Let's look at number one. Let's calculate the oxidation number of Cr in K2 Cr2O7. Okay, let me see on next thing. Okay, so the one that I start with is what is the one that we're going to be looking at its oxidation number. So how can I find oxidation number of Cr in K2 Cr2O7? Guys, what I'm going to do is remember how do we write charges? We know that K is positive. Okay, so I'm going to say K is positive. You guys, you can go to a group. What is this? Periodic table. You know, K it is in group one. Okay, so if it's in group one, it has an oxidation number of +1. Okay, of +1. But how many Ks do we have? Can you see I have 2 Ks? So I need to say 2 +1. So they tell me that there are 2 Ks they're off, okay? And then I'm gonna say plus. How many Cr do we have? 2, but I'm looking for Cr, so I'm gonna just say 2 Cr plus 7. What is the oxidation number of oxygen? Remember, oxidation number of oxygen, it is minus 2, except in what? Except in hydrogen peroxide, or in peroxides to be more specific. And now the question is, what is the net ionic charge? Okay, what is the net ionic charge? We go back to this rule number 7. It says neutral compounds have a net oxidation number, so not net ionic charge. Net oxidation number of how much? Of 0. So this should balance out what? To 0. And then we just do basic algebra. 2 plus 2Cr minus 14, it is equal to 0. And then you'll have 2Cr, it is equal to 14. When I take it to the other side, minus 2, it is 12. And then you'll see that Cr, it is plus 6. Plus 6. Guys, the plus is very important. Plus 6. Okay? Plus 6. So what I'm going to do now, I'm going to remove this and then take my answer here. Okay? Cr is what? Plus 6. This is just you doing your algebra, guys. I'll show the algebra and then remove it and then come back here. Guys, I did not say Cr it is 6. This is absolutely wrong. It needs to be Cr it is equal to plus 6. Number 2, guys. I'm talking a lot. Let's consider number 2. S. Okay. Letter S in sodium sulfate. Okay. Now, remember, there are things that we already know that are exactly like that. Sodium, it is in group 1. So we know it has in group 1, it has a what? A oxidation number of what? Of +1. Okay, guys, I don't need to refer to the periodic table now and then. Here it is. Here it is. Okay, guys, it is Na. And then you should know this off by heart, guys. This is the last time going back. So we have how many NAs? We have 2 +1 NAs. Can you see I'm saying +1? plus sulfur. How many sulfur? Is just one sulfur plus 4. And oxygen, it is how much? Oxygen, it is -2, except in peroxide. I will always tell you about the exceptions, guys. The net oxidation number should be equal to what? To 0. Let's do our basic algebra. It's going to be 2 plus letter S, sulfur, minus 8, it is equal to 0. And then sulfur is going to be equal to 8 minus 2, which is plus 6. So I'm going to remove this and say my sulfite is plus 6. Guys, very important, plus 6, plus 6. 3, number 3. Let me consider sulfur again in what? In a different compound now, in H2SO3. Okay? Hydrogen sulfide. So it's going to be hydrogen. Remember, hydrogen, it's only, okay, hydrogen, it is in group 1 and it is plus, unless now we have a, unless it acts with other elements. We have semi non-metal, unless it acts with other metals. Okay, and maybe I might come back here and say add something here. -1 when reacting. Sorry. And -1 with non-metals. Okay. -1 with metals and +1 with non-metals. Maybe this will make sense. So hydrogen, there is no other metal. Sulfur and oxygen are just non-metals. And then it's going to be 2 oxygens. Sorry to the audience. It is going to be 2 hydrogen, and hydrogen, it is +1, plus my sulfur plus my oxygen. There are 3 of them, and it is -2. It is equal to 0. And then you'll do your mathematics, guys, and then you'll see that your sulfide is +4. Ooh, Mudimo. This is very important, the plus. And then let us move to now the ones that I referred to as having the compound ion, the oxidation number, the net oxidation number of the compound ion, it's its charge, okay, on the ion. So let's consider sulfur. I like sulfur, ne? I know. Sulfur in H2SO4 minus. There is no H2SO4 minus. I know HSO4 minus. So we say, guys, it's still basic things. It's still the same process. It's just that we're going to say hydrogen there. One of them, it is +1 plus sulfur plus 4 into, guys, this negative, we're going to use it somewhere. Conserve it for now. Plus oxygen, it is what? -2. It is equal to. Now, what is it equal to? Here we said it was equal to 0 because we had nothing here. We had nothing there. But in this case, we have something. What is that something? It is -1. So it's going to be equal to -1. I hope it makes sense. And then it's going to be +1 sulfur. 1 minus 8, it is -7. It is equal to -1. Sorry. And then sulfur, it is just -1 plus this. It is plus 6. Sulfur likes to be +6, ne? I see. So I'm going to remove this and then take this to the side and then highlight this. Okay. And then let me do the last one for the thingy. And then we have what? So that I wrap up the video. I think it's now too long. And so that, let me see. let's find sulfur in, actually, let's find Cr in Cr2O72 minus. Okay, when you do that, you're gonna say, okay, we want chromium, so you're gonna say chromium. How many chromiums do we have? We have 2 plus how many oxygens? 7 oxygens, and so oxygen is always minus 2, and it's gonna be equal to what? Can you see the net oxidation number? It is what? Minus 2. And then when you do your mathematics, you see that your chromium, it is -2 plus 14, which is 12, and then it is plus 6. Don't cram these numbers. They vary depending on what they react with, guys. Okay. And now I'm in a position of showing you H2O2K. Okay. Now that we know how to do these calculations, I now can prove this to you now nicely without trying to add up weights. We are saying oxygen, hydrogen, we already know. Remember, we start with the cations and then go to anions. And I know hydrogen, it is a cation, so I'm going to start, it's going to be 2 plus 1 plus 2 oxygens, and then it's going to be equal to the net, it is 0, and then I have 2 plus 2 oxygens, it is equal to 0, and then, okay, it's fine. This is oxygen. I'm not sure if I can write it like this. Allow me to write it like this, oxygen, so that I do not confuse it with the 0. Oxygen, and then 2 oxygen is going to be equal to -2, and then oxygen is equal to -1. Remember, we said oxygens are equal to -2, except in peroxides. This is what we said. Okay, except in peroxide, where oxygen it is what? -1. So guys, I repeat, special cases, when I wrap up the video, we have special cases again. We have special cases. The special cases is oh, I need to do this example now. This one. Let me make it the last example, number 6. Hydrogen, oxygen, Cl. Now let's find of Cl. Okay, let's find Cl in this. So if they tell us to find Cl, it means it's gonna be hydrogen 1 plus 1, and then plus oxygen, it is -2, or you can say plus -2 plus Cl, it is equal to 0, which is 1 minus 2, which is -1, plus Cl, which is equal to 0, and then Cl, it is equal to plus 1. So can you see that here Cl, it is equal to plus 1. But what did we say? We said all halogens are supposed to have negative. Okay, this is now in contrast to what we said. We said halogens have oxidation number of -1. So what causes this? The reason that causes this is that hydrogen is positive, yes. This is a cation. But these two are anions. So one of them needs to fight for its negativity. Okay, so we're going to say oxygen is more electronegative. Can you see it is more negative than Cl? Okay, so it means oxygen is more negative than chlorine, rather. So oxygen is more electronegative than Cl. Therefore, it will maintain its negative state. Therefore, Cl will be +1. Y will be +1, so that it balances the net oxidation number. I repeat, oxidation, so oxygen is more electronegative than Cl. Therefore, it maintains its negative state, therefore causing Cl to have +1, so that it balances out the net oxidation number. Okay, So yes, guys. So it's basically that. I don't think there are any catches there. No catch. No catch. They will tell you pint of what and then it will be beautiful. Okay? It will be beautiful, guys. I promise you. I promise you. Okay. Except for fluorine though. Fluorine, well, fluorine, fluorine is always a negative, by the way. And I think I was supposed to add that halogens are usually -1 and positive with oxygens. Let me add it here. Where they are positive. This excludes fluorine, which is always always -1, even with oxygens. So yeah, I just hope it here, guys. I just hope it here. So yeah, the exceptions, I think you are aware of them. I noted them down and all of that. So thank you very much, guys. Let's go to the next video where now we'll be now discussing further more about what exactly is redox reaction. So thank you very much, folks. Hopefully you are willing to join me on the next one. Okay, thank you very much.